Welcome friends, this is the second video in the series. In this video, I'm going to be teaching how to work with components. So, I'm going to be using a very simple circuit to explain this concept. I'm going to be designing a stable multivibrator using the 555 timer IC. So without wasting much time, let's quickly open the Proteus simulation software. The Proteus is up. What I'm going to do first is to pick and select components that was used in the circuit design. Few components was used to achieve the schematic. So to pick and select components in Proteus, all you have to do is to click on this icon which says P. You click on it, it's going to pop up a dialog box which allows you to easily search or pick components. An easy way to pick and select components in Proteus is to type in the components that you want. So for our case, we're going to need battery, resistor, capacitor, 555 timer IC, so on and so forth. So let's start with the battery. So what I'm going to do is to type the keyword battery. Now doing this, you might get multiple results for your search. Like for the case of this component, we have different results for the keyword battery. At times you might feel intimidated on which of the components to use. My advice for you here is, whenever you're designing a circuit which you want to use for simulation, I would recommend you go for the active or device library. But if you are designing a circuit which will be used for PCB design, I would advise you to look for one that has a PCB footprint. Okay, so we are not looking at PCB design right now. We are only looking at simulation. So what I'm going to do here is to select this one, is to select battery that is under the active library. Now for you to do that, just simply double click on it. Now that will be added to the Proteus environment. So we're going to pick up the next component, let's say resistor. I'm going to remove the battery and type resistor. As you can see, the resistor has a lot of results. You can see the value over here. Now same thing here, you might feel intimidated on which of the components to use for the simulation. Like I said, when you are doing simulation, usually go for the active or the device library. You can equally go for these two. It's okay. So what I'm going to do is to pick either of this or this. So whichever one you want, you can go for it. If you take a look at it very well, you'll see that this component has a PCB footprint. You can see it over here, while this doesn't have. So you can choose whichever one you want. It's okay. So we're going to pick up the 555 timer IC. Just come over here and type in the 555 timer or 555. Now doing that, you're going to get different IC. This is the one we want, the 555 timer. You can see the schematic and you can see the PCB preview right here. I'm going to double click on that. Then next, I'm going to pick capacitor. I'm going to look for active library. Scroll down. Okay, this is also good. You can go for this, all this, all this. Now I like this because it's polarized. You can easily tell which is negative or positive. So I'm going to make use of this. I'm going to double click on it. Then I'm going to you can still use this if you want, it's still okay. I'm going to pick this non-electrolyte capacitor. If you take a look at the schematic, you'll notice there are two different kinds of capacitor used here. One of them is an electrolyte, while the other one is non-electrolyte capacitor. The next components we're going to pick here is the LED. There are different LED in the Proteus. You have the green, red, so on and so forth. Whichever one you want, you can simply get that by including the color to it. For instance, you can say LED red or red LED. This is what you get. This is what you're going to get. LED red. If you want yellow, just simply include the color LED yellow. If you want green, LED green, so on and so forth. So let's just pick green. LED green. I'm going to double click on it. Okay, I think that will be all for now. So if you are done picking and selecting your component, all you simply need to do is to click on OK. After selection, you notice that the component has been added to Proteus environment. Before we begin with the design, I'm going to zoom the environment. After selection, to design the circuit, all you need to do is to select the component that you want, then over to your working environment and drop. For instance, let's start with the battery. So what I'm going to do here is to click on battery, over to the working environment, click there, then click again to drop. This is our battery. So this is how you connect a component in Proteus. So I'm going to pick the 555 timer nest, click to bring it up, then click to drop. Then next, I'm going to pick the resistor. So I'm going to click on resistor. Our resistor, if you take a preview of it, you see it's in horizontal form. So if you want to place this in vertical form, all you have to do is to rotate. So you can rotate clockwise or anti-clockwise. Another way you can rotate the resistor is after you've connected the component, you can still rotate by right clicking on the component, then use rotate clockwise or rotate anti-clockwise, or you can still use the shortcut key num minus and num plus. So what I'm going to do here is I'm going to rotate this to be in vertical form. I'm going to pick up another one. You don't have to select the resistor again. All you just have to do is to click on the working environment. Automatically it brings up the resistor. So we're needing 3 resistors. The next is the capacitor. So I'm going to click on the electrolyte capacitor, place it, I think it's somewhere here. Then next is to get the non-electrolyte capacitor. I think that was placed somewhere here. Then the last in our list is the LED. I'm going to pick the LED. I'm going to rotate this anti-clockwise and drop over here. Okay, I think that will be all for the connection. So next is to wire up the circuit. To wire up the circuit, I'm going to do a little adjustment. To move this towards here. If you want to move a component, you first of all click on it, then click hold and drag. That is how you move components in Proteus. Click on it first, you click hold and drag. I guess this is the complete component for the stable motive vibrator. So next, we're going to wire up the circuit. To wire up the circuit simply means to connect the terminals. So here what I'm going to do is I'm going to start with the battery. Click on the positive terminal, then you over to whatever point you want to connect to. Now let's say I want to connect to this resistor. I'm going to click on it. So you over from the positive terminal of the battery to the resistor. Now that is going to create a connecting point. That is going to create a connection between the two components. So next, I think the VCC going to be connected to the positive also. Same thing with the reset. I'm going to just connect it instead of using the button. I'm going to connect the reset to the VCC. Then I'll connect the positive of the battery to the ground of the 555 timer IC. I think same thing with this capacitor. I'm going to connect it to ground, and this terminal will be connected to pin 5. Then pin 6 and 2 are connected together. Pin 6 and 2 are connected together, which is connected to the electrolyte capacitor. Then the other terminal of the electrolyte capacitor is connected to ground. Okay, then this pin is connected to this, while this terminal is connected to this. Okay, in the 555 timer, in a stable multivibrator using 555 timer, pin 3 is the output. So we're going to connect the output to this resistor and LED, which is in series. So here I'm going to click on pin 3 over to the terminal of the resistor, click on it to drop it there, which is going to create a connection point between the two components. Do the same thing here, click, hold on this point, connect to the other point. Lastly, I'm going to connect the other point of the LED to ground. Now if you take a look at this junction, you notice that two wires are crossing that path. Now these two wires, they are not touching each other virtually. They are not touching each other. It's just crossing over. If the two wires are connected together, you're going to see something like this. You're going to see a junction there. You're going to see a dot junction, a dot connection there. Now this simply means that these two wires are connected together. But if it's like this, if it's crossing without a dot, it simply means they are not connected together. Same thing with this, it simply means they are not connected together. But here, if you take a look at this, you notice that this wire, this and this are connected together. So that will be all for the design. So next is to rename the value. To rename a value, you simply double click on the value itself, or you can still double click on the component. But doing that, you're still going to get the value. So resistance is 10k ohms, or you can double click on the value itself. That's it allows you to easily do that without viewing or seeing other parameters. So you can use any option of your choice. So I'm going to rename this 10k ohms to 1k. I think that's the right value. Then I'm going to change this value to 100k. Then for the capacitor is going to be 10 microfarad. This is going to be, let's use 240. I think 240 is okay. Then here I'm going to use, I don't really need much, let me use 0.01 microfarad. Okay, then lastly for the battery, I'm going to change that to 9 volts. Okay, I think that'll be all for the design. Then if you want to start the simulation, all you simply need to do is to click on the play button, which is at the bottom left of your environment. I am getting something wrong here. Oh, I forgot to connect pin 7. So pin 7, it's connected between R1 and R2, so this point. Okay, so let's run the simulation again. Okay, that works fine. That will be all for this video. For support, please like the video and subscribe to the channel. See you in the next video. Bye.